addition of vector, right? So let's we have a vector v1. Okay, basically we have a vector v1 is equal to 1 and let's 2. Okay, this point, and second vector is v2 is 3 and 4. Okay, okay, that's how we have a vector. In a vector addition, we simply add this both of the vector. Okay, so uh, for that, so simply we writing v1 plus v2 is equal to 1 and 2 plus 3 and 4. So in final answer is a 4 and 6. Okay, not minus 4 and 6. So this is simply vector addition. Okay, simple add, just add two vectors. That's a vector addition, right? And similarly, we calculating the magnitude of that vector, magnitude of vector, magnitude of vector. So calculating magnitude of vector is easy, right? We in this video, we calculating simple magnitude of a vector. So what is the magnitude of vector? Okay, magnitude of vector v1, right? So magnitude of vector v1 is nothing but 1 square plus 2v square, nothing but 5. There is a magnitude of vector v1, right? Similarly, of this representation, how the vector represent in a graph when you draw a graph and see how the graph are represented. That's addition. Okay, and after that we understanding the real world application that useful in a machine learning, data science, all the concept, right? First, understanding the representation first. Okay, so let's start with the representation. Let's we have a graph. Sorry, I want to draw proper line. Okay, so this is the graph. Okay, so this we have a graph. Okay, not to making it properly, no problem. I hope you understand. The 0, 1, 2, and 3, 4, and 5, right? This is x axis. Similarly, draw 1, 2, 3, 4, and 5. This is a y axis. Okay. So a simple draw. This is a v1. Okay. v1 is a 1 and 2 at somewhere point is can sum that point. Similarly, when talking about a v2, 3 and 4, 3 and 4, it means that point is coming someone else. Okay. This is a vector v1. This is a vector v1, and similarly, that no, that's increasing simultaneously. This is a v2. Okay, so v1 and vector, and when we add this both of this, so point are 6 and there's a point are 6. So this point will come somewhere, right? This is the point 1 comma 2. This is a 3 comma 4, and this is a 4 comma 6. Simple adding a vector. When you initialize the negative, so in negative cases, graph of addition is clear. Graph of when you adding the both that vectors, so graph some of the different thing, right? But I hope that the addition of vector you understanding the representation as well. Now time is to understand the real world application. Okay, we understanding the vector addition, but where to use that? In when we learn machine learning concepts. So, many cases that we use the word that's a vector addition. Okay. So first we are going with the body, but that's a very important concept. When you learn about the neural network. Okay. So first, okay, this is the real world application, real world application, right? real world application. In real world application, we simply first example is the word eventing. Word eventing basically is a adding a two words in a simple term, right? How to understand that concept? Let's we have a basically each word represent a vector. Okay, in simple terms, just like we have a vector data. Okay, and that's some points are something like 0. 0.1, uh, 0.2, and 0.3. Similarly, we have a vector signs. Okay, and this vector representation are something like 0.4, 0.5, and 0.6. That's we have two vectors of vector data and sign. Basically, what evening it's been when you learn about the neural networks. Okay, in neural network, that's very useful when you learn about the neural network. So in that case, simply be adding that two vector and signs, basically the vector data plus vector sign. Right, is nothing but means we add both of vector. So the 0.5, 0.5, 0.7, and 0.9. Okay, so this is the vector addition. Okay, similarly is a useful when it's one of the algorithm is a bagging and boosting. Okay, bagging and boosting. In bagging and boosting, you when you learn about the concept just like random forest, random forest, right? Random forest, same. Similarly, you learn some concept just like XGBoost, right? This random forest, XGBoost, all the concepts, they learn the weak learners, right? Weak learner and they train a model and get every model give outputs, right? Its own output. In that particular case, you simply use a vector addition of all the output and you give a final output, right? You give a final output. Something like that, you create a different concept and different thing that you will use in a word basically a vector addition, right? Similarly, in a computer vision, right? It's a word eventing are useful in a computer vision, computer computer vision. Similarly, clustering. Okay, all these concepts are clustering when you learn about the unsupervised learning, unsupervised learning. Okay, in a unsupervised learning for a clustering. Okay, for a clustering. Okay, for a clustering using the vector addition, right? And similarly, the training neural networks. Okay, understand? Uh, Training neural networks, training a neural network. This all the terminology that we will understanding when you learn about the all the concept of backing boosting, then eventing in neural network, for a clustering. That's point you need to vector addition, and that is simple concept. That's a vector, and simply add both of the points. That's simple for a vector addition. Okay.